afternoon and welcome back again for this lecture of BSc Semester 1 Electronics, and we are studying transducers today. So we'll start with that. Just hold for a moment. Yes, I should. So good afternoon again, and I will start with the presentation directly. So we'll be studying today transducers, right? So we'll start with this, and I guess we need to complete it at the earliest. So I guess it is visible to you all. So yeah, so today we are going to study about the transducers. Let me introduce myself, Dr. N.D. Mishram, Head and Associate Professor, Department of Electronics, Sri Mathura Das Mohta College of Science. And today we are going to study this topic of transducers, Unit 4, Paper 1. So let us start and let us try to complete this topic today itself. So yeah, what is a transducer? Introduction to transducer. I guess you have understood. A device which converts a non-electrical energy or a one form of energy into an electrical energy, that is called as a transducer. In electronics, it is actually an important topic where we require some of the physical quantities to be converted into electrical quantities to measure it, right? And for that, we require these types of devices which are going to convert actually the physical data into an electrical quantity. And that particular device is called as a transducer, right? So, for example, you might be knowing the temperature, which is supposed to be the physical quantity. Now, this temperature is to be converted by some of the device into its equivalent electrical parameter, right? Electronics parameter, right? Like voltage, resistance, capacitance, anything it might be, but it should be the equivalent of that particular parameter, say the temperature. So that particular device is called as a transducer, right? And we define it in general form as it converts one form of energy to another form of energy, and this can be an electrical form, so that we can use it for the reading purposes, right? So this is that device, and if you understand in this sort that this is a black box, and what we are trying to do is we are trying to give a pressure in this block, and it is now being converted into an voltage, right? So this is the main job of a transducer, to convert a non-electrical quantity into an electrical quantity. So yeah, I guess you have understood this. This is the basic concept of the transducer. So let us again yeah. So this is the block diagram of a transducer. Transducer contains mainly two parts that are closely related to each other: the sensing element and the transduction element, which means that one part is to sense that particular parameter, that physical parameter, and the other one which is actually going to convert it into an electrical one. Right? Now that sensing element is called as a sensor. It is a device which is going to produce measurable response to change in physical conditions. So that sensing element is first connected to that physical parameter, right? Then we are having this as a block diagram. You are able to see my screen. This is the sensing element. I guess I'm audible. You are clear? Hello? Am I audible? There is a sound like humming. Am I audible? Yeah, anybody can unmute and let me know. Omkar, am I audible? Hello?
Yes, sir.
Thank you, beta. So ये screen दिख रही है बेटा आपको? So this is an sensing element, and this is the transduction element, and which is going to convert this physical parameter, which might be pressure, temperature, force, etc., into the electrical signal. That might be voltage, current, or say resistance or capacitance. Anything it can be. So this is that particular device is called as a transducer. Now this is the block diagram. We'll just rush up sometimes. So yeah, these are some of the characteristics which are essential for a transducer. It should be rigidness. So we'll study this one by one. So rigidness, linearity, repeatability, accuracy, high stability, reliability, dynamic range, and physical size, speed, response, sensitivity, and cost. Yes. So we'll read that. Operating principle. The transducers are many times selected on the basis of operating principle. We'll study this and that. So what is the concept principle of the principle of working of that particular transducer? That is me. So we have different types of transducers. The principle might be resistive, inductive, capacitive, optoelectronic, piezoelectric, many and many more. So we'll study these. Sensitivity. Now sensitivity is the main parameter of a transducer because it is going to sense that particular say physical parameter. So it should be a sensitive device. It should sense the smallest change in that physical parameter and it should be able to detect that, right? So that is called as sensitivity. Then we are having operating range. The range of that device means up to what range it is going to work. So if for a thermometer of a human thermometer, temperature thermometer, we require that we should be able to measure the range around say 90 degree to 110 degree. So in that case, what happens? We are concerned with only that particular range of temperature. Other than that, it is not. We don't require that. So for that, we should also consider the operating range. So operating range is another basic important say factor for a selection of a transistor. Now the accuracy, high accuracy is assured means the, the change in that physical parameter should be recognized by that particular transistor. So that is accuracy. Then cross sensitivity, it has to be taken into account when the measuring mechanical quantities. There are situations where the actual quantity is being measured is in one plane and the transducer is subjected to variation in another. So there might be cross sensitivity also, means we are going to measure two different platforms in one transducer. For that can be done. These are errors, errors going there. And these are some other factors which are responsible for a nice or a good transducer. So loading effect, environmental compatibility, insensitivity to unwanted signals, and much more. Then yeah, so these are some of the classifications of transducers which are being classified uh, which are being classified according to its working principles. So the transducers are classified as active and passive devices. We will study this. Analog and digital transducers. Then on the basis of transaction principle, we can use primary and secondary transducer. Then transducers and inverse transducer. We'll study this in here. Right. So active and passive. What are active and passive devices? So active transducers are those transducers which does not require external source or power for their operation. I hope you are getting this, what I'm trying to tell you. So these transducers do not need external power supply, external energy source for of power for their operation. Means they are going to generate their own power, right? And therefore they are also called as self-generating type of a transducer. So active transducers are those which does not require external source, external energy, right? Whereas the passive devices uh, requires the external energy or power supply for their work. The active transducers are self-generating devices which operate under the energy conversion principle. And second, as the output of active transducers, we get an equivalent electrical output signal, example temperature or strain to electrical potentials without any external source of energy being used, right? So I guess active transducer you have understood, the transducers which does not require external source, external energy for their operation. That is called as active devices, whereas the passive devices, so piezoelectric transducer, yeah. So this is a transducer which does not require energy. Just we are pressing it, and if you are able to see, it is going to generate the voltage, and it is going to generate the voltage in both the direction, positive as well as negative, right? So when you press this, piezo means pressure, right? So whenever this device is pressure, when a pressure is applied to one phase of this transducer, then it generates the voltage. So that this is an active sort of active device. And as you are able to see, we are not going to apply any of the energy, any of electrical energy or excitation energy to this piezoelectric transducer, right? So it is self-generated, right? So this is active device. Again, these active devices are classified into some more parts. These are called as photovoltaic, thermoelectric, electromagnetic, piezoelectric, chemical, and others. So these are some of the classifications of active transducers, right? So photovoltaic, thermoelectric, wherever the word thermo comes, uh, it is concerned with temperature, right? And electromagnetic, we are going to study this. We are going to see all those. See, we are going to see all those instruments. So yeah. So active and what is a passive device? So passive transducers are those transducers which are which requires these transducers need external source of power for their operation. So they are not self-generating. They are not self-generating, right? So like it is the reverse of active devices. A DC power supply or an audio frequency generator is used as an external power source, and these transducers produce the output signal in the form of variation in resistance, capacitance, inductance, or some other electrical parameter in response to the quantity to be measured. So I guess you understood. Whenever we require the external source, then that type of a transducer is called as a passive transducer. Okay, this is again, if you are able to see, this is LVDT, linear variable differential transducer. Now we have a magnet over here, and we have two coils, primary and these are secondary coils. And as these are moved, it automatically the current is being generated. So we are having an AC current. So for that we require excitation source for this primary coil. As soon as we apply some primary current to this, then it generates, right? So this is called as a passive transducer. Okay, classification of passive transducer. These passive transducers are being classified like variable resistance, strain gauge, thermistor, potentiometer, photoconductor, like LDR. Then we have variable reactances, which are inductive transducers, inductive, capacitive, variable reluctance, variable permeability, and LVDT. Optoelectronic devices, which consist of photoemissive, photoconductive, Hall effect, etc. So these are all the passive transducers that we have. These are classification of passive transducers. And primary and secondary, yes, initial level, primary and secondary transducers. Some transducers contain two parts, the mechanical as well as electrical device, right? So two parts we are having. The initial part where actually the sensing of the physical parameter is done. That particular is called as the mechanical part. And the other one which is actually going to convert or actually going to generate that electrical quantity, and that is called as the another thing. So we are call that as primary, and the other one we call it as secondary, right? So primary and secondary transducer. I will see this also. So yeah, if you are able to see over here, this is a strain gauge transducer. Now this is a diaphragm. So this diaphragm acts as a primary sensor, and this actually acts as the secondary transducer. So whenever this is being this diaphragm is being pressed, so this act as a first mechanical uh, primary transducer, and due to which the strain is being pulled given to this wires, and that's why there is a change in the resistance over there. So this is called as the primary, and this is the secondary transducer. So if they are both, will have a transducer, but we can differentiate between primary and secondary transducer, right? So yeah, now actually classification of transducers according to the transition principle. Now how they are going to work. So according to the principle of their working, we can classify those transducers. So these transducers are classified in this fashion. So we are having, according to the working principle, we are having capacitive transaction, electromagnetic, inductive, piezoelectric, photovoltaic, photoconductive. So we are having, depending on the principle of, say, working. So capacitive will go one by one over there. So according to the transaction, we are having the first one as the capacitive transaction. What is a capacitor, right? So as I told you, capacitor is nothing but two conducting plates separated by a dielectric medium. It's called as a capacitor, right? Or a non-conducting medium, that is called as a capacitor, right? You have studied this capacitor in your 12th electrostatics chapter. Right. So we'll study this. So the typical, yeah. So the relationship between the capacitance and the size of capacitor plate. Yeah. So we are having two plates here, which we call it as the conducting plates, and this is separated by distance d. The area of cross section of this plates is a. So the formula of capacitance comes out to be epsilon zero epsilon r a by d. Epsilon by epsilon 0 epsilon r by a by d, where d is the separation of distance between the plates in meters, and c is the capacitance in farad. Epsilon 0 is absolute permittivity of vacuum, and uh, epsilon r is the relative permittivity, and a is the effective overlapping area of capacitor plates, that is in meters square, right? So this is the concept of capacitor. So whenever we can change the size of the plates, we can change the distance, we can change the say non-conducting medium between them, which is actually epsilon 0 epsilon r. So depending on this change, we can have different sorts of capacitors. Therefore, this is the concept of a capacitive transducer, right? So working principle of capacitor is the capacitance is going to vary according to the distance. So whenever I need to measure a distance, so I need to measure the distance, I can vary the distance between these two plates, and accordingly I will be changing the capacity, right? So this is the basic principle of a capacitor. Let us try, yeah. So we can change this. Epsilon can be varied, so the non-conducting medium can be varied, so accordingly we can have different types of capacitor. If you put paper in between these two plates, we'll be having paper capacitor. If you change air, then air filled capacitor. If you put oil, then we have oil filled capacitor. So we can change the non-conducting medium, and we can have different sorts of capacitors accordingly. So this is the first principle, that is capacitance. Then electromagnetic inductions. So electromagnetic conduction means which is consist of electromagnetic, and depending on the Faraday's law of induction. So whenever there is a coil, and whenever there is change in the magnetic flux in associated with the coil, the EMF is induced in that particular coil. So if you are able to see over here, we have a coil over here, and we have just a coil over here, and we are just changing the magnetic flux, that is the magnetic field. This is the north and south pole of a magnet. So we are putting inside and we are taking out. So accordingly, if you are able to see that the EMF is induced in this coil. So this is the concept of the electromagnetic type of a transducers, right? So the principle is whenever there is change in magnetic flux associated with a coil, the EMF is induced in that particular coil, right? So we can convert this displacement, we can change in this magnetic flux in the form of, say, voltage or EMF. Right. So this is the electromagnetic induction principle. Then, yeah, these are some more example where we can induce current in a coil. So this is there. These are the types in which we can do that. So the same concept is there. Electromagnetic induction. The same concept is again can be used in this fashion also. So this is a coil, and this is a coil, and yeah, so when you change when you put this magnet inside this coil, there is a EMF is induced in this coil, right? So you can change the polarities of the magnet, you can change anything. So this actually works as a magnet. So this coil is now working as a magnet, right? So this can also be done, and because of this, the EMF can be induced. And sorry, as you are able to see, you can say measure the displacement or distance. Small distance can be measured by using this coil. So distance is supposed to be another physical parameter which we are expecting to change, and depending on the voltage which is going to induce in this coil, we can uh, we can calibrate it to the displacement, right? So this is that electromagnetic principle. Then we have according to the inductive principle. So inductive principle is same. Inductive means whenever there is change in, say, self induction and mutual induction. So whenever there is change in magnetic flux associated in the same coil, right, then that is called as a self induction. So this is inductive principle. Then we have piezoelectric. Yes, I've shown you whenever we pressurize the crystal, then the EMF is induced in that, and accordingly we'll have voltage. So this is a piezoelectric. We'll go in fast. Yeah, photovoltaic transistor. Now, what do you understand by a solar cell? Where we are going to convert this solar energy into electricity, right? The basic concept of solar or a photovoltaic is whenever the sunlight is say focused on these semiconductors, so there is EMF is generated, and this can be stored in batteries, and that can be used. So this is the concept of the photovoltaic transaction, right? So this sunlight is being say focused on these pallets, and uh, in turn it is going to generate electricity, right? So it is going to say it is going to give you a current, and that can be used. So this is the basic concept of photovoltaic transduction, which is going to convert a solar energy into electrical energy. Uh, yeah. So there are some more. Yeah, this is some physical structure. Uh, this is the physics which is associated with this photovoltaic electricity generator. So this is P type, this is N type, and this is the positive depletion layer. Then this is the negative, and whenever we focus solar light on to this plate, then this EMF is induced, and will have a current flowing through this, right? So this is the basic concept of that. Yeah, then that we are having photoconductive. In photoconductive transition, the measurement is converted to change in resistance of semiconductor material by change in light incident on that material. So whenever the intensity of light is supposed to be measured, right? So whenever intensity of light we require to measure the intensity of light, then this photoconductive transaction is comes into play. So the main concept is as you go on increasing the intensity of light, it is going to vary the resistance, right? So those are called as the photoconductive transition. The examples are LDR, light dependent resistance, right? So depending on the intensity of light, the resistance of that particular transducer varies, right? So this is photovoltaic conduction. Then inverse transducers. Yes, as we are having transducer which converts non-electrical quantity into electrical quantity, we have inverse transducers also. Now the inverse transducer, what they do, they converts electrical quantity into a non-electrical quantity. For example, a speaker. So a speaker is going to convert the non-electrical quantity into sound. So speaker is the best example of a inverse transducer, right? So transducer which converts electrical non-electrical quantity into electrical quantity, and uh, inverse transducer is that which converts non-electrical electrical quantity into an non-electrical quantity, right? So these are transducers, I guess. These are passive transducers. So passive transducers, we are having resistive transducers, resistance. I told you capacitance. Similarly, we are having resistance. Resistance is equal to rho L by A, where rho is the where rho R is the resistance and rho is the specific resistivity of a specific resistance of a conductor, right? So, yeah, I guess. Huh. So rho L by A, where rho is the resistivity of the conductor material that is in ohm meter, and A is the cross sectional area, L is the length of the conductor, and R is the resistance. So if you vary any of those parameters, you can change length, you can change area of cross section, you can change the resistivity of that conductor. So accordingly, we'll be having change in this resistance. So this resistance we can increase or decrease the voltage. So this is that. Now this resistance are of again different types. Actually, four types. There are potentiometer, which we call it as pot, which is going to vary, which is used to vary the sound. Pot, we have used pot to vary the voltage. Strain gauge. Then we are having thermistors. Then resistance thermometers. Right. So potentiometer, that is pot, strain gauge, thermistor, resistance thermometer. So these all are the types of potentiometer. Yeah, the potentiometer, which is, yeah, this is somehow looks like this. So this is a wiper which is going to rotate on this resistive strip, and accordingly the resistance is going to vary. Okay, so the electrical circuit is like this. The electrical circuit is like this. So the main center wiper is going to change, right? And accordingly, we can vary the voltage. This is a pot. Then, yeah, I guess this much is enough for today. We will just repeat what we have studied. We have studied some of the basic of transducers, uh, concepts of transducers, active and passive transducers. Yeah. So we have studied this. Uh, Yes, we have studied this transducers, basic concept of transducer, introduction to transducer, a transducer which converts a non-electrical quantity into an electrical quantity is called as a transducer. Then, uh, yes, this is the block diagram of a transducer. Then these are some of the basic requirements of a transducer. Transducer selection factors. Uh, these are some of the factors which are required for to select the transducer. Then we have active and passive transducer, analog and digital transducer on the basis of transaction principle, primary and secondary transducer, transducer and inverse transducers. So active transducer, which are actually supposed to be a self-generating type of transducers, which are called as say which does not require any external energy or source. Those are called as active transducers. We have seen that those. This is the best example of piezoelectric transducer, active transducer. The classification of active transducers, we are having photovoltaic. I have shown you photovoltaic, then thermoelectric, electromagnetic, piezoelectric, chemical, and others. Uh, then yeah, passive transistors which are not self-generating, so they require external source of energy for them, right? So we are applying some energy on this, and accordingly there is the voltage is activated. So the classification of passive transducers, uh, yeah, then we have studied this primary and secondary transducers. Then, according to transconduction principle, we have a capacitive, electromagnetic, inductive, piezoelectric, photovoltaic, photoconductive, resistive transducers. And we have studied this capacitive transducers. I have told you that two conducting plates separated by a dielectric medium is called as a capacitor. And if you change one of the variable from this, you will have a different capacitor. Uh, then we will have electromagnetic transaction like this. Whenever there is change in magnetic flux associated with a coil, then there is a change in magnetic flux or EMF is induced in that, right? So Yes, inductive transducers, then yeah, piezoelectric transducer, photovoltaic. I have told you those are solar cells, and this is the basic concept how solar cell works. We are having N type and P type semiconductors. Then yes, this is how electricity is generated. This is photoconductive transducer, which is going to work according to the say intensity of light. Yeah, and then we have studied transducer and inverse transducer, right? So transducer which converts a non-electrical quantity to electrical quantity, whereas inverse transducer is which converts a electrical quantity to non-electrical quantity. For example, it is a speaker. So I guess this much is over for today. So we have also studied passive transducer, resistance, and we have completed this resistor. So there are four types of resistive transducers: potentiometers, strain gauge, thermistors, and resistance thermometers. Then we are also having yeah, this is the pot where this wiper rotates and accordingly the voltage can be varied. So this is a potential divider network where we can divide the voltage according to the change in this wiper. And if you are able to see here, we require some voltage source over here, and that is why it is called as a passive device, right? So, what resistance is a passive device. I guess this much is enough for today, and we'll again schedule class tomorrow. So be there. Thank you very much for listening this class, and we'll definitely be sharing this. Bye. See you. Stay home, stay safe, and take care. Good day. If you have any questions, we can say. Thank you very much. Stay home, stay safe. Please take care of yourself, and we'll be continuing these classes again. Thank you very much. Bye. See you.